All right. Well, incoming rate has slowed a bit. So
You
let me
should start.
welcome everybody to our open mic night with Michael Moussourakis and Mike Valenti. And this is a product quality cleaning workshops webinar. And it's going to be a great one because we haven't filled it full of PowerPoint slides. We're just going to actually go through a few, and then we're going to open it up to the people that have logged in and are attending this webinar. You can see probably on your screen a Q&A button, so that's what you'll use, and those questions will come straight to the panelists, and then we can answer them. So our guests tonight or today are Mike Valenti with Hubbard-Hall. He's the Director of Technology, and you can see his expertise here. A lot of experience working with many different customers, both in solvent and aqueous cleaning. Really a specialist in non-ferrous metals for sure, and his aluminum webinar was one of our most successful ones. And from Alconox, we have Michael Moussourakis, who's a VP of Corporate Strategy. Also 20 years of experience in all kinds of areas, biopharma and medical device, and process optimization. And one of his past webinar on cleaning glassware involved in botanical extraction was one of our
That
more
was pretty.
successful
Yeah.
webinars. And yeah, we had a lot of signups for that one too. So we thought
I
we'd bring
think
them
we
back
now
for
say cannabis now. I think
yeah.
It's okay.
botanical was
The
when it was
botanical
still,
extractions.
yeah.
Mechanical extraction.
That's
We
right.
are, tomato production or
Yeah, that's right.
was
It's a burgeoning field, I guess. Yes.
yeah.
And then
We
our hosts here, Barbara and Ed Kanegsberg, are the cleaning lady and the rocket scientist. They're with BFK Solutions. They're consultants in critical cleaning and author of the 2-volume set here, the Handbook of Critical Cleaning. Still a great resource.
yeah. Always fun to read articles in our own book that we've forgotten that we wrote, which is cool.
That's right.
And here is Darren Williams, the professor, who is professor of physical chemistry at Sam Houston State University. He teaches thermodynamics, but he's understandable. He's the leader of the research group and co-chair of the product quality cleaning workshops and webinars. He does cleaning trials and formulates cleaning chemistries. And here's how to reach him and us.
That's right. And I put in a commercial here for the parts cleaning workshop that's going to happen April 2nd. And this is going to be in at the PMTS in Cleveland, Ohio. And so we are going to bring our equipment up there. It's going to be a hands-on workshop. We've done hands-on workshops in the past. In 2018, we did a virtual workshop during all the COVID shutdown in 2021. And this is going to be back to hands-on. We're going to have lots of activities for you to do and lots of ways to learn by doing.
So instead of floral centerpieces, there will be ultrasonic tanks, and you'll
That's right.
actually get to do cleaning. And
You don't get to take them home.
no, you don't get to. No, it's not. No,
That's right.
No, it's,
The sticker under your seat. Yeah.
under your
There
seat.
will be things you can.
There
take
will
home.
be a few.
That's right. A few things.
Take home. But the idea is that testing the new techniques, and beyond ultrasonics, we can even demonstrate cyclic nucleation, cavitation, things that you can test with your hands and look at, even test some of how clean is clean enough. Really good. It sticks with you better. I certainly learn better that way.
All right. Very good. And so, Mike, tell us a little bit about, I'll say Michael. I put Michael and Mike in there so we could distinguish between the two. So, Michael, tell us a little bit about Alconox. Yeah.
Thanks, Darren, and good to be with you guys again, of course. For those who don't know, Alconox has been around almost 80 years, not quite as around as long as Mike's company's been around, but we'll hear about that. Third generation family ownership, and we focus solely on detergent manufacturing, starting in the labs, and now over the decades progressed into other critical cleaning industries, including biotech, pharma, medical device, as we alluded to before, botanical/cannabis, but also some industrial, solar, aerospace, I cut that off, electrical, things of that nature. Distributed around the world, all 50 countries, all 7 continents, yes, including Antarctica. And we really pride ourselves on technical support. I oversee our technical support group, and it's always fun to interact with our end users to find out what new and exciting problems there are in the cleaning world.
Yeah. All right. And then we've got a little bit of
Mike.
information here about Hubbard-Hall.
Yeah, so Hubbard-Hall, so we're only 100 years older than Alconox. This is
We're
actually,
just youngsters.
yeah, y'all are babies. So Hubbard-Hall is based out of Waterbury, Connecticut. The company's 175 years old. This is our 175th anniversary this year, actually. Sixth generation family ownership. We actually sell into three main areas. That's metal finishing. So any kind of metal finishing process you can think of, from electroplating chemistries, anodizing, phosphates, just about any type of proprietary finishes for metal surfaces. And then as part of that business, surface cleaning and preparation is one of our largest product areas. And then we also do wastewater treatment. So we literally, in any metal finishing operation, we're cradle to grave. Our chemistries go in, and then we can treat them on the back end. And we are actually a distributor. So our relationship to Alconox is we are a distributor for Alconox products. The Alconox products serve us as a product line that we don't offer those specific types of approved products for different applications. So that's what our relationship with them is when we need a specialized cleaner for, say, a food contact application or a medical application where our products aren't approved for that, we would go with an Alconox product. So that's how we are interact with each other. So.
Fantastic. Yeah, that's great information. And so today's agenda, we're going to just start out with Michael getting us started with a few food for thought, and then Mike Valenti will continue with some key considerations for aqueous cleaning. And then we're going to open it up to the webinar attendees to ask their questions. And already some questions are coming in, so that's great. So if something comes to mind, click that Q&A button on your screen, and you can type in your question. And then when we're answering it, you won't see any questions until we start answering them, and we'll hit live, and then the questions that we're answering will pop up on your screen. So let's get started.
So there's a few questions I kind of threw up here just to get conversations going. These can all be presentations in and of themselves. So I'll give very, very quick and, pardon the pun, dirty answers to good cleaning questions. If you have a brand new cleaning application, how do you know whether you choose an aqueous or a solvent? Like many times, many of the answers that we're going to have today is going to be, it really depends on your specific application. There are all sorts of wonderful solvents out there that have worked for decades, but there are concerns about flammability, corrosiveness, harshness, carcinogenic. The EPA, as Barbara well knows, comes down on these kinds of chemicals more and more.
Don't
You need to
blame me.
monitor. You need to monitor, what solvents are okay, both nationally and locally for what you need to do. We only manufacture aqueous detergents, so we tend to recommend those, but there's certainly times where a solvent is needed. So you really have to look at the regulatory, environmental impacts, and exactly what your surfaces are that you're talking about. Another question we get fairly often is the SDS states that the aqueous detergent that we have should not be released into the environment, prevent from reaching drains, sewer, or waterways. But we also say that the detergent is drain safe.
When I
What's
saw that
wrong with you
question, I
guys?
thought,
You
oh,
guys-
this is great. I want to hear this one.
Are you guys lying to us? No, the answer is we're not lying to you. The drains in laboratories, drains in manufacturing sites, drains in pharmaceutical, medical device, you name it, they're all treated drains. So those are things that we talk about being released into the environment, and being drain safe, because these detergents are designed for use in manufacturing sites, laboratory sites, those type of environments. For the most part, the detergents could be put into untreated drains, but things that have phosphates, things like that, can cause growth, because these detergents are biodegradable. What does that mean? It degrades by bio. It grows things. So you want to avoid into untreated drains or kind of just dumping it, into your pond next door. But treated drains, laboratory, manufacturing sites, that's what we're talking about, and that's what's drain safe.
And Mike M, doesn't it also depend on your local POTW people, which can be on
Absolutely.
the street where you live? It's sometimes they get real specific about what they want.
Absolutely. We say our detergents are federally drain safe because, or the ones that we say that are, because federally pH 2 to 12.5 is safe to go to drain, but Northern Maine, Southern California, everywhere in between, let alone the rest of the globe, are going to have very different regulations based on municipalities, localities, and different needs. So,
Mike M, what's before we leave the topic, what's a treated drain? Someone asked. Ray asked, what's a treated drain?
those are drains that have wastewater treatment facility associated with it. Drains that are hooked up to healthcare facilities or laboratories or manufacturing sites. Those will have treated drains because they have processing going through the sewage that's going out of that facility. A home and a hut in the mountains is not going to have a treated drain, but manufacturing sites and related sites will.
Okay,
Some will.
some will. Okay,
Some will.
Well, you always do want to check with local.
yeah.
That is the preeminent thing. Everything is local in these types of
Yeah,
situations.
one of the things that
VHS,
people don't,
Scott.
one of the things that people don't realize is there are federal regulations. So in a metal finishing facility, there's a lot of regulations about what metals can be so the cleaner may be safe to go down the drain, but the contaminants in the bath
Yes,
may not.
thank you. Yeah.
So there's actually 6 categories that the federal government, if you do those processes in your facility, you cannot put metals down the drain, even if the cleaner or whatever the chemistry is safe. So you got to be really aware of what you're doing, right? Just because somebody says something is safe to put to drain doesn't mean that the stuff you're contaminating the bath with is safe to go down the drain. So
Yeah, excellent point. Yeah.
We work with nuclear decontamination sites and labs, and I imagine Hubbard does too. Yeah, guess what? Not okay.
not okay. You can't put chrome to the drain, right? There's certain things you cannot put to the drain. So
Nope.
So quickly here, concentration versus temp versus time in cleaning, particularly aqueous cleaning, but it can affect all types. These are levers that you have at your disposal. If you add more detergent, if you add more temp, and you add more time, almost ubiquitously it helps. But there are applications where you can't use temp, or you can't raise the temperature, or there are times where temperature actually there are a few residues that temperature makes it worse. So you're able to extend the time or extend the concentration. So I look at those as dimensions of control over cleaning. And part of a good cleaning process optimizes all 3 of that and more. But those are the main ones. Cleaning aluminum in aqueous versus solvents. This is something Mike can certainly talk about too, a little bit. Aluminum can be reactive. It depends on whether it's been abraded, if it's anodized. This kind of relates back to the very first question. It would really depend on the residue and your setup and, again, environmental and regulatory needs, whether you would choose aqueous or solvent for aluminum, because there are answers in both. Mike, did you want to add anything to that one?
yes, I mean, when I get to my slide. So I have some show and tell, but choosing aqueous versus solvent cleaning, there's a whole lot of questions you have to ask.
Yeah.
And there's so many factors. I mean, literally I have an entire 45-minute talk on this. So it really, there's so many things. I mean, I'll give you an example. I got show and tell, right? So this is a part off of a jet engine, okay? this part, this is a bent titanium tube,
Should we,
right? Can you
can
see
we
it?
change the view so everybody can see it?
Yeah,
Darren?
thanks, Barbara. That's a good idea.
Right. Okay, so this is a bent tube, and there's really nothing on the outside of the tube, but on the inside of this tube is what's called a bending lubricant, and you can't see it, but these bending lubricants are very viscous, and they get way on the inside of the tube. So if I take this part and I boil it in any aqueous cleaner that you can ever formulate, it's never coming out. You might get it to drain out like honey. So this particular part has to be solvent degreased, and it's part of the fuel system of a jet engine. So that's pretty critical that lube is removed. So this is an example of an application where you're not going to replace solvent degreasing with aqueous degreasing. So
It always depends. Absolutely.
it
Yeah.
depends.
It
Mhm.
really depends. It really depends.
So Darren, you can switch back. All
right, sure.
I'll hit that
We'll
last
move over
question.
to- Yeah. Shall we move over?
So another one that comes up, what is free rinsing versus residue free? We say our detergents are free rinsing, but is it residue free? So a free rinsing detergent is something that can be rinsed away. In the world of aqueous cleaning, free rinsing is something that can be rinsed away completely with proper, appropriate, and thorough rinsing. So when you say a detergent is residue-free or interfering residue-free, it requires the rinsing. So the free rinsability, saying a detergent is free rinsing, is what allows you to make a residue-free surface via the appropriate rinsing. It doesn't mean you don't have to rinse. That's why I put this question up there, because a lot of times people will come with a detergent, seeing it's free rinsing or seeing it's residue-free and think that means you don't have to. It's not free of rinsing. It's really rinsed away.
Yes, yes.
And I always break it down to something very simple. Think Dawn, not Windex. And that's really the bottom line. It's a detergent is like Dawn or a soap that you have to suds up and rinse away, whereas Windex or other kind of alcohol is a solvent that can largely get away with not having to be rinsed. And that's the key, one of the key differences between solvents and aqueous cleaning. So hopefully this prompts some questions, and Mike's going to go through a few himself, and then we just open it up to you guys.
Yeah, no, that's a good thing. No, the comment about free rinsing doesn't mean you don't have to rinse. It's kind of like the no clean flux. Sometimes there's other reasons to clean it.
No, it doesn't mean it's not magic.
It just means you
Yeah.
can't. It's difficult to clean.
Getting to that, to get free rinsing, does that imply that there's an additive that stays on the part so that it looks like it rinses free, or?
No.
I feel like that was a good layup question, Barb. Of course not, because then it would not be residue free.
Yeah.
That's
Well,
the
you know,
whole key.
You can
Free
have.
rinsing implies that you're rinsing.
Yeah.
Okay, just
Okay,
check.
if you're not rinsing, there is no free rinsing aqueous cleaner. There's no
Yeah.
such thing as a cleaner that magically just comes off the part without good rinsing.
Yeah, because we have a question in there that
Think of it this way: cleaners are contaminants.
yes, thank you.
Great
Okay,
point.
so
Great
the
point.
cleaner is a contaminant on the part if you don't remove it.
Mm.
So the whole point of the rinse tank is to remove the cleaner contaminant off the part. So if you don't have good rinsing, you still have a contaminated part. It's just a different contaminant than what you started with. And sometimes it's worse than what you started with
Yeah, if you don't rinse, yeah.
if you don't rinse.
And
And
the real thing is you're exchanging that original contaminant with one that's more soluble so that it can be rinsed. Yeah.
Or it's detrimental to the surface of the metal, or it's detrimental to whatever you're doing downstream.
Yeah.
Right? Let's just say, for example, you're powder coating a part or putting a coating on it. Well, that cleaner residue might inhibit the adhesion of whatever that coating is, and then the coating's going to flake off.
Hmm.
So yeah, so rinsing is really removing the cleaner contamination from the part. So
A mass displacement event, which is
yes, it's a mass displacement.
It's
Yeah.
it's a very powerful part of true critical cleaning, and it's why a lot of pharma and medical device, that's their tried and true first effort, aqueous.
Most people that have cleaning problems, I'll tell you, over 50% actually have rinsing problems. They just don't realize it.
Yes,
So
that's
you get
Yeah,
there.
that's a good point.
which if we, there's oh, go, I'm waiting.
Okay, let's
So
switch over to
Mike.
Mike Valenti's talk
Yeah,
or pieces of
we get asked, so we get lots of people, internally and externally that ask us, hey, we got this part, right? We need to clean it. What do we use? And this says aqueous cleaning, but it could be solvent, degreasing, whatever. So there are just some key things. If you're a processor and you come to us or to Michael and you say, hey, I need this part clean, these are like the most basic questions that we have to know before we can recommend any process to you, regardless of what it is, right? And if we don't get answers to these questions, it's very difficult for us to solve whatever your problem is. So the first one is, what alloy are we cleaning? Right? Are we cleaning a ferrous alloy, aluminum alloy, a copper alloy? And why is this important? Because all of these alloys react differently with chemicals, right? So if I have a steel cleaner that cleans a piece of carbon steel well, it might destroy a piece of aluminum if I put the aluminum in that same cleaner. So what alloys were, and aluminum has 8 different alloy classes, for example. So when somebody comes to us and says, I need to clean this piece of aluminum, the first question we ask is, which alloy is it? Because those all react differently. So number one thing we have to know. And then of course, the second thing we have to know is, what are we removing? What is the soil? Like, is it an oil? Is it a water-based dispersant coolant? Right? Like, if we have to know what the soil is, so we know what the best chemistry is to remove it. Right? Like the example I gave you of these tubes, that bending lubricant is a chlorinated paraffin. Well, we know if you tell us it's a chlorinated paraffin, we know there's only certain things that are going to remove that. Okay. And then the next thing is the geometry of the part. So again, that tube, it's bent, or does that tube have areas that have holes, recess areas? Because we have to understand, if we have to get inside of a part to clean it out, we may need a cleaner with a certain surface tension profile, right? Or we may have to rinse that part a certain way. So the geometry of that part is important. And then the other things that people never think about when they think about, I hear all the time, well, Mike, it's just a tank of soap, right?
Yep.
It's just a tank of soap. So these last 4 things are all the important or high level things. So when you make up that tank of soap, what happens over time? Well, where does the stuff coming off the part go? Well, it goes into the tank. So I use the analogy, if you wash your dishes in the sink and you never change that water, dish water, what eventually happens? It becomes so dirty that the dishes just stay dirty. So what you have to do to the bath itself, how much chemistry is in the tank? What is the soil load? Can I rectify that? Those are all really important when you're looking at cleaning in an aqueous system, because we have to be able to understand and maintain. They don't last forever, is the point. And then in aqueous cleaning, I use the term, every gallon of aqueous cleaner you make up is eventually going to become a gallon of waste somewhere. What do I do with that? How do I get rid of it? Because you'd have to get rid of it.
Yes.
Like, it doesn't last forever. So one of the questions do you have a waste treatment system? right? If you don't, what are you going to do with it? Do you have an evaporator? Are you going to have somebody come pay and haul that chemistry away, right? And if you have a wastewater system, there's certain chemicals that are extremely detrimental to your ability to wastewater treat. So that's an important question. What's going to happen to this waste? Because it's eventually, what are you going to do with it? So we need to know that. And then the other thing that people, don't realize is, you have to heat all these tanks. And so there's an energy component. So you got to have heaters. You have to have steam. Is it electric? All these things, like that goes into equipment. So we're going to ask you, what kind of equipment do you have? And is your equipment capable to even get to the temperatures needed to clean these parts based on the soil we're trying to remove? So these are kind of the things, if you're looking for someone to supply you a cleaning process, this is like the most basic questions you have to be able to answer. So if you come to either of us and you can't answer these questions, it's hard for us to help you without answers to these questions. So that's why we have this up here.
Yeah, that's a great point.
That's all I have on that.
All right.
Great. Shall we switch to the 4-screen?
Yeah, we certainly can. Yes.
Yeah, I think that'll be good.
I'm excited.
Everybody all okay? Everybody smile.
Yeah.
Okay. We have a bunch of questions. Well, one I don't quite understand, but I'll ask it anyway. Can I use pressure jet pumps to get residue free for parts with cleaning agents? In other words, will pressure jet pumps is that enough?
So what they're talking about is impingement in a spray system.
Okay, they're
right?
just yeah.
So impingement does help certain types of cleaning processes. And, depending on what the process is, I don't know what their process is. Impingement rinsing, a lot of times if people have a hard time getting cleaner off of, say, in a soak tank, we will recommend spray nozzles to spray the parts as they come out of a soak tank to help with rinsing. So yes, impingement will help with rinsing. It is a way to get,
Doesn't it depend on how you get access to the part?
It does. So impingement only works on the surface, the external of the part. If you have to get cleaner solution out of the inside, the impingement, you're not going to magically get the water inside the part. So you need to have immersion. But a lot of people, there are lots of different pieces of equipment that can do both.
Yes.
There's even machines out there now that will pull vacuum during the rinsing step and pull the solution out of the internal. So it comes down to the part that's where part geometry is really important.
Yes.
I would expand that definition into agitation or mechanical action.
Yeah,
that is always elbow grease, right? However you define it is always a big help, whether it's impingement, ultrasonic, the vacuum cyclic nucleation, or
inductors,
shaking it,
Yeah, inductors. I mean, there's certain lines that will, rock baskets up and down. I mean, there's no end of mechanical ways, but impingement on the surface of parts will help rinsing. Absolutely.
So I have two related questions. And somebody Fred writes that his high school chemistry teacher taught us to triple rinse. My biology teachers taught me 4 or 5 rinses.
Okay, so
biological.
I'll take that one. So here's what we teach. Yeah, go ahead.
How much is enough? Semiconductor processing needs molecularly clean, I believe. And I'm gonna relate that to somebody who wrote that their budget said they could allow them to get a new aqueous cleaning process. They needed it fast. but the capital equipment budget only covered one wash and one rinse tank, and the parts don't look real clean. What should we do?
Okay, Michael, I'll start and you can finish. All
Let's
right.
do a two-parter.
So what we teach, so how much rinsing you need depends on lots
Yes.
of different factors, right? So I'll give you two examples. So, you know, if Apple's making an iPhone and they're anodizing this aluminum or whatever, they need really good rinsing
They do.
prior to their process, right? Like they need really, if you're doing remanufacturing of engine parts, you don't need fantastic rinsing, right? But what we teach is counterflow rinsing if you need very good rinsing. So in a counterflow system, you have multiple tanks and just the rinse water moves in the opposite direction the parts go. So imagine you have 3 tanks, you're putting fresh water in the last tank and then these counterflow back, right? So that last tank is always clean water. So when you counterflow tanks, that gives you a factor or a multiplication factor of mix. So imagine 3 counterflow rinses is like having almost 10 static rinses, right?
Yeah.
So and how much you need, there's actually the NASF actually on their website, if you go to the National Surface Finishing website, they actually have a link and you can actually calculate based on, there's a formula and you can calculate depending on, you know, the quality of water you need, how many rinses you need, do you need counterflows, how many of those tanks do you need? So all these things, there's calculations and things you can do, but how much you need depends on the level of contamination of the parts. So it's an open-ended question, but we teach counterflow rinsing if you need really good rinsing.
So would somebody, I know what counterflow rinsing means. Let's make sure we all understand what counterflow means.
Yeah. So again, so a counterflow. So let's just imagine we have a cleaning tank and rinse tanks. And so my parts are going in the cleaning tank and then they're going down the line through the rinse. So in counterflow rinsing, the water in the rinse tanks flows counter or opposite to the direction of the parts, so that the first tank is the dirtiest rinse, the second tank is cleaner, and the third tank is always fresh water.
It's like this. This is the cleanest. It flows down this way, and the parts go that way.
Right. They go opposite. They go counter each other.
Yeah.
Sometimes
we're always,
to
we're putting fresh water in the last tank, so that tank's clean, and it's overflowing to the second tank, which is overflowing to the first tank, which will overflow somewhere else, into the drain or the wastewater, or sometimes even back to the cleaner tank if you want to recycle the water. But the key is we get the benefit of many freshwater rinse tanks in a much smaller profile.
So what happens if you're stuck with brand new equipment that only has one rinse tank?
Then you need to overflow that rinse tank. And
okay,
again,
that's good. Yeah.
So then you have to talk about how many times per shift or hour or day do I need to turn that tank over to keep because remember, you have to have a target for that rinse water. You have to have some type of measurement, whether it's conductivity, total dissolved solids, which are really the same thing, right? You have to have some type of target that you have to hit that says, I need this rinse tank to be blank amount of cleanliness, pH, dissolved solids. Then once you know what that target is, then you can turn that tank over enough to hit that target.
And that depends on your customer somewhat. What the product's going to be used for.
It depends on what the requirement is for that particular part or that particular, you know, a lot of it boils down to the processing. So if you're doing, for example, if you're doing powder coating and you're doing a zirconium pretreatment, that part's got to be very, very no contamination. So you need many rinses and you need water that is clean, almost cleaner than city. You need DI water in that. Okay.
Or maybe not. If it's
Yeah.
too clean, you might have
Maybe
to.
RO water, DI water a lot of times in those cases.
If you
Right.
have DI, you might get corrosion. Either.
Right. But the application that you're doing, whereas like say on an electroplating line, you may not need the water to be that clean because it's going to go through so many other chemistries anyway before it gets to the plating tank. You don't need it to be that clean. Now, if it's a medical application
Yeah.
and it's a part that's going into somebody's body,
Yeah.
I mean, so again, it really depends, but you have to know what the target is. You have to be able to measure something to know that. You have to be able to measure that water. And there's charts. Again, there's a lot of information out there you can go get that says, this is what water quality level I need to get to, and this is what I need to do to get there.
There's a rule of thumb that every rinse knocks down the remaining detergent and residue 2 orders of magnitude. So
Yeah.
triplicate rinsing takes you down 6 orders of magnitude, but analytical labs may do 12 rinses. So
Yeah.
really, as everyone's
Yeah.
been saying, it depends. You have to know what you're targeting, the industry that you're in, the requirements that you're gunning for.
Yeah.
And I'll say, even though it sounds maybe a little counterintuitive, if you have only one rinse, you're likely using more water.
Yes,
You got
absolutely.
to change it so many times.
No.
And if you're heating that water, you're going to use a lot more energy.
If you have one rinse, you're going to use a lot more water because you are literally going to have to turn that tank over so many more times. Whereas in a counterflow system, remember you only got it. You don't have to turn over those tanks that often because that last tank's always clean.
Yeah.
Could we throw in a solvent question next?
Sure.
We're doing solvent being organic solvent. So,
Yep.
Is there a preferred temperature range for vapor degreasing solvents? Would a boiling point of 200 to 260 F be too high for most applications? Understand that high temperature solvents used for cleaning optics and some other materials might be a concern.
So all solvents have their temperature ranges. So I don't know what solvent they're using, but boiling point of solvent's based on the boiling point of the solvent. I mean,
Sure.
so once you hit the boiling point, you hit the vapor phase. There's generally a high cutoff so that you don't blow the solvent out of the degreaser past the condensing coil. So I don't know what solvent they're using, but there is no recommended range. There's a recommended range based on the solvent system.
Yeah, and doesn't it depend can it damage the part? Doesn't it depend on what you're cleaning? Because different metals can be.
Yeah, so I mean, so if you're cleaning brass, for example, and you get brass too hot, it will air oxidize. You'll tarnish it. So yeah, again, this goes back to the chemistry of different metals. Heat is on what we call soft metals. Copper alloys, aluminum alloys, high temperature is damaging to those alloys. So, but there is no if you're running a vapor degreaser, you better be running the temperature range. You better have your degreaser set at the manufacturer's range for that solvent system.
Yeah.
And that's an important point too, because your degreaser has been probably set up for a particular solvent system, and you can't just throw another one in there and turn it on.
No, you cannot.
Do you want to ask?
Now, one advantage of a higher temperature is the vapor condensation on your part only happens when your part is cooler than the vapor.
Correct.
And so a higher temperature will stretch out that vapor cleaning time a little bit. But again, you've got to balance the different effects.
And a lot of times with non-ferrous metals, I have personally killed large magnesium parts.
Oh yeah, magnesium. The biggest thing you have to be concerned about in vapor degreasing with those parts is the actual solvent degrading itself.
That's true.
And stabilizing the solvent. That's your biggest worry, is stabilizing the solvent system.
Sure.
Yeah.
Yeah, you want to ask
Yeah.
that? We're moving back.
Yeah, well, here's one that relates to how you determine how clean it is. Is there a quantitative way to determine if a part is clean or not? I know people use water break free as qualitative, but for some things that doesn't seem to be good enough.
So maybe Mike M could take that one for
It-
starters. So
I mean, Mike V touched on it a little bit already. You know, there's a whole array of what we'll call specific and non-specific methods, meaning general methods, or you're actually looking for a specific residue. So general methods, Mike talked about conductivity, TOC, water break is actually a fine one. Visual inspection is a legitimate way to determine cleanliness. Low angle flash photography, all kinds of things like that. And then you have specific methods where you're actually gunning for something in particular. You can do HPLC to look for a residual surfactant or a residual protein if you're worried about your actual biotech product or your medical device product lingering behind. So there are a whole array of different tools that we can bring to bear. We actually have a book that actually has a whole chapter dedicated to the different types of specific and non-specific methods. Shameless plug for my book.
Yeah. Was that the handbook that you're talking about?
Yeah.
oh,
yeah,
his
yeah.
the Alconox book.
Yeah.
Darren was kind enough to do the forward on that.
Yeah.
So plug for Darren too. But the idea is, as we've been saying, it depends on your industry and what level of cleanliness you're really targeting. And that will help at least narrow down which method you want to pull out of that toolbox.
You want me to? So
Sure.
yeah, so a quantitative. So if you're looking for something quantitative, to give you a number, you'll see a lot of people use something called Dines testing. If you're interested, we just wrote a white paper on Dines testing versus another method that Darren's very familiar with called water contact angle. And both of those methods will give you a quantitative number. Contact angle gives you a much more precise number. And so a lot of our customers use Dines for kind of a, they'll pull parts off a line, and if it's got Dines blank in a range, then they consider that clean. We actually like the contact angle method better because it actually shows you multiple types of contaminant. It'll tell you if your surface is contaminated with a hydrophobic contaminant or a hydrophilic contaminant. So, for example, let's say you do have bad rinsing and there's cleaner solution left on your parts. A Dines pen is going to give you a false positive that that part is clean. Okay. Whereas if you do water contact angle, you'll know immediately based on the fact that you can't read a contact angle, probably, that the part actually is failing for bad rinsing. So,
unless that rinsing leaves a lot of surfactant.
That's what I'm saying. If there
Yeah.
that's why that method is good, because if I take a part out of a tank and I say my spec is 40 Dines.
Yeah. Okay. Yeah. Dines.
Here's the thing. So if you have a hydrophilic contaminant on the surface of a part, every Dines pen from 30 to 70 will fail. Will give you a pass. It will say you'll get wet out. Every one of them will say it's a pass. Well, that's all well and good as long as you're looking for an oil. Okay.
Yeah.
But if you leave surfactants on the system, okay, and that's bad.
Yeah.
That Dines pen is going to give you a false.
Yeah.
Also, it's the same thing as water break. That part's going to be water break free, but the reason there's no water break is because there's something on the surface causing the water to wet out.
Yeah.
Well, that cleaner residue is bad, and if you get it downstream, where if you do contact angle, that is a real number. You can actually see the droplet of water and how it behaves on the surface. Now you're going to know that the contamination is being caused by a water-based contaminant, and it will force you to go back and look at. So that's why we like that method versus other ones, because it helps you actually determine whether or not whether the part's clean or dirty, but is there any kind of contamination left on the surface?
Okay.
So
It's good.
Can I switch? Can we talk about drying equipment? Because the question is, do you recommend drying equipment such as a column or homogenizer with compressed air through a filter after final rinse? So I guess the larger question is, how do you dry? And
well, that, again, it's so dependent on the part. And so let's take a piece of carbon steel. I don't care what it is. And that's the final thing. There's no coating. There's no, if you leave that part wet, even with an inhibitor in it, you're going to get rust spots. So you need to dry the parts, whether it's an air knife, it's blowers, it's an oven, you better dry the part. If spotting is a problem, if spotting is a aesthetic thing, you don't want to see spots, you better dry the part. So I've seen people that don't, that take parts, they come out of a rack and they just take an air hose and blow the parts off and it's fine. Again, it depends on, I think in Michael's area, he can talk about it, these critical cleaning areas, they don't want to see anything on the surface. So drying is probably really important in most cases.
yeah, I think it's very.
I have an old saying that stagnant water is a bioreactor.
Yeah.
Because it will, unless you're in outer space, I don't care how clean your room is, hood, what have you, if you have a drop of water, it's going to grow things. Now, it may not be a big deal if you're dealing with an industrial application, but in critical healthcare, medical device, pharma, biotech, what have you, it does make a good sense to dry. And that's part of our, our 9 dimensions of cleaning. Drying is a very key one, being the last one, because you don't want to have the all that effort you've made in cleaning and sanitizing the part. You're going to leave water hanging out there, even if it doesn't damage the surface, which, as Mike obviously pointed out, it can. Even if it's a surface that's not susceptible to drying spots or water, you got a pool of water there. It's going to grow stuff. Not good.
And I think too, how clean is that air if you've got compressed air?
That's
I ruined a good pair of Dockers back in the day when my analytical chemistry students were cleaning out their burettes, getting ready to do a titration, and they were running that oily compressed air into their burettes to dry it. Frustration. I said, don't do that. That air is oily, and I turned it on full blast, and it blew oil drops all over my waist. And I said, see,
so drying is one of those things. Again, it's an application dependent, but if you had to ask me, you should always be drying your parts somehow. I mean, metal's reactive, and water, believe it or not, water is reactive to metal. So that's why solvent degreasing, that's one of the actual benefits of solvent degreasing, is there's never water in contact with the part, so you don't have to worry about that. So, but
and
that's
if you
why
pull them slowly out of that cold vapor zone, then they come out dry.
That's why we get the inhibitor business too, right? Because you have to have inhibitors for all these metals to keep them from corroding, because they've been exposed to water at some point.
And that corrosion inhibitor is a residue, which
it is,
isn't it?
It absolutely is a residue. Has to be.
Yeah. We still have a little bit of time, and
still a lot of questions.
And a lot.
Yeah, that's right.
So I don't think we're going to get to all of the questions, but I think
we can answer them all later.
I think we can.
Yeah.
If we don't get to them during the hour, I think we'll figure out a way of answering them and returning the questions to everybody.
As best as we can, and if we don't understand the question, we'll try to make contact with you and that kind of thing. We get this question periodically. What are your thoughts on using eductors in an aqueous cleaner tank for typical metal finishing, i.e. steel parts? Will eductors improve cleaning?
The answer is yes. I like eductors. I don't like air being introduced into a tank because air creates bubbles on the surface of parts. And if there's a bubble on the surface, the chemistry is not going to get to it. And it also creates a lot of foam in the tank. So I like eductors better. But again, it depends on the formulation. If it's a high foaming detergent or cleaner, eductors can still create foam. So it really depends on the formulation, but I prefer eductors to air sparge.
That's a great point.
Yeah.
That's a great point. Would either or both Mikes like to talk about mayonnaise formation, about forming emulsions in the tank?
Mike, you're all that's all you might. Go ahead and talk about emulsion.
Well, how that affects cleaning, or what?
How it affect? I'm going back and forth among questions, and I sort of see what kind of looks like emulsion questions. One would be affecting cleaning, the other would be affecting the cleaning agent itself.
So there are many aspects to an aqueous detergent, one of which is their surfactant, and those surfactants will emulsify certain types of residues, oily residues, organic residues. So you'll get a formation of a micelle that is, I mean, we could do pictures, but essentially it's a cage that forms around the particulate or the oil globule or the whatever it might be to help now make that water soluble and go into solution so that, and this is what we hit at the beginning, can be rinsed away. So it's just one aspect of aqueous cleaning, but it is often a very key aspect. So surfactants are responsible for creating these micelles and therefore emulsions, which is just a fancy way of saying make soluble in water, things that otherwise would not be. So that's how you get something to emulsify with a good surfactant.
Yeah, so we put emulsifiers in cleaner formulations, like Michael said, to basically isolate the oil droplets so they don't redeposit. They're removed. It keeps them from redepositing back onto the metal, right? So most cleaner formulations are either emulsifying or they're displacing, right? So the formulation either encapsulates the oil or it displaces it to the top of the tank. And then you have to skim or you have to have it away. What we tell people is if you're going to run an emulsifying system, the key consideration to have is there's only so much oil that system can hold. And once you hit the saturation point, you got to get rid of the cleaner and restart. So that's the downside. Now there's filtration and things you can do. There are ways to mitigate that, but in general, and then in the metal finishing industry, there's certain processes. For example, if you're running barrels, things that are turning or baskets, you never want a cleaner that displaces oil to the surface, because then what happens is you're just turning your equipment into the oil. So,
yes.
So in those types of processes, you want an emulsifying system, okay? If you're running a spray washer, for example, you want a cleaner that displaces oil and can be skimmed out of the sump because you don't want to respray the emulsion into the spray chambers or back onto the parts. Mm-hmm. So a lot of times whether you pick an emulsifying system or a spray system depends on the equipment itself and how the parts are going to be exposed, because you're trying to prevent resoil. That's the whole point of emulsification, is to prevent resoil.
It's a balance now.
Yep.
Point. We need to understand the jargon.
Okay.
And what is it? How do you spell dyne? And what is an E dash ductor. So it's how do we,
Dyne is D-Y-N-E. It's surface. So a dyne, I don't have, I do actually.
Dyne is a unit of force. So,
This is a typical dyne test kit, right? So inside this kit are little pins, and essentially these are different alcohol solutions, and each one of these has a different amount of alcohol. It's different surface tension, right? So you can take these pins and you can literally draw a line on the surface of the part, and you're either going to see the solution, you're going to see it break, you're going to see it, it's going to become discontinuous, or it's going to look like a magic mark on the surface, right? And there's a lot of other things that go into determining if you're using the right one or not. But this dyne, this is the what we're referring to, the dyne test. These are standardized solutions that you buy, right? So,
and each one of those has a surface tension, and if that were surface energy, and if that surface energy is higher than the surface, it'll break up. If it's lower than the surface, it'll stay flat. Yeah.
Yeah. So this pin is a 34 dyne. So, right. So like Darren said, if the surface energy is different, it depends on the surface, and all kind of things affect this, the metal itself and also the contaminants, right? So, but that's how those work.
These are all, I'm sort of bouncing.
The eductor, I don't remember what.
An eductor is just a nozzle that's underwater.
Yeah.
Okay.
So sprays are above solution, like nozzle sprays, like a spray. An eductor is basically a pump pumping the solution, but the nozzles in an eductor system are immersed.
Okay.
And they're usually
think of a jacuzzi.
A jacuzzi.
And you have the jet.
Have eductors. Good example.
You have the option of adding or not adding air to that.
Right.
The eductor would not have the air. The jacuzzi without the air.
The air sparger would.
Yeah. One more, probably, Barbara.
Oh, too many.
We've been running through. I mean, this has been great.
I know. How quickly can DI water, in particular, grow bacteria?
Okay, so I'm sorry.
I'm not touching that.
Depends. What kind of environment are we in? Is it humid? Is it dry? What is the classification of the air that we're in? How many viable particulates are in the air to begin with? The short answer is pretty quickly. I think, even if it's in a reasonably clean area, under reasonably clean conditions, I would say on the order of hours. It kind of depends on where things are. So it's not going to happen like instantaneously, but stuff settles. Even WFI has a limit, unless it's sterile.
I'm sorry,
WFI is allowed to have a certain amount of bioburden in it. So even
it's
WFI
very hard to eliminate life. Ideally,
that's right.
Yeah.
That's the basis of life, water, right?
So
that's right.
And then the very final question, if you can sit for, is using isopropyl alcohol for drying. Where was that question about?
Love it. Forms azeotropes. If the part is compatible with it, use it. It's a good way to try.
We have a number of people that do critical aerospace parts, and they use IPA to dry the parts to make sure there's no.
It's a displacement.
It's just a displacement.
And that was my solution to my pipettes and burettes for my students.
So.
And off the record, you've got to be doing a little bit of cleaning with the IPA itself.
Yeah, that's right.
It's got to be clean. Right. It just has to happen if it's soluble.
Well, it does help remove. So if you had some like surfactant residues or something on the parts, the IPA generally will remove those too. Just be careful using it. It is flammable. I always, I see.
Great point. Yes.
I see people with open tanks of IPA, and I just,
oh my gosh.
Yeah.
Or
It-
acetone, always
Or
fun.
these are all flammable solvents. And
Very.
Yeah.
Avoid
Very-
using them in an ultrasonic, please.
Yeah,
Don't
please.
be very
them.
careful how you use them.
So
So-
we're,
Oh, so I think that's been, I mean, unfortunately, we're out of time. We have so many more questions. We will follow up with an email, and you'll be able to hear from all of us and giving our various takes to your questions. We'll
yeah,
send
we're
out a
gonna
link to the
make an
video.
effort. Going to
Yes.
make an effort to answer as many of these questions as we can in writing. You've given
As
us
soon
homework.
Yes,
As soon as we possibly can.
that's right. In our free time.
Yes,
In our
in
free
our,
time.
Yes.
so Darren, you want
One more plug for the parts cleaning workshop in the spring.
yeah.
You can go to our page there, shsu.edu/PQCW. There's lots of little pictures there. Hover until you find new workshops. Click that and you can register.
That's in person.
That's right. Thank you so much, Mike and Mike. It's
Yep,
been great.
anytime.
That's
A
wonderful.
lot of fun,
Great-
guys. Thank you.
Yep.
Yeah,
Great,
this was a
great.
really good one.
Great participation and great speakers. This was
And
both
thanks
nights.
to our audience who
Yeah.
and
They,
That's
Whoa.
right.